we now talk about refraction at spherical surfaces. So say you have a light source right here, and this light source is emitting light. So you have these light beams, they are traveling in air. So say air has refractive index N1, and you enter into glass which has refractive index N2. So at the surface, these lights will bend. So the one which is traveling along the principal axis, this will not bend, but all other lights are bending. And then the image is formed right here behind the surface. So you have a light source here, and the image is formed here. So for this slide or this lecture, we are going to use two important formulas. So the first formula is this, you have seen in mathematics, that limit of theta goes to 0, sine theta by theta is 1. So that basically means that when theta is small, sine theta is approximately equal to theta. But you also know when theta is small, that is theta is very close to 0. So theta is small, theta is very close to 0. You know that cos theta is approximately equal to cos of 0, which is 1. So now you can see that tan theta, which is equal to sine theta by cos theta. So when theta is small, this becomes equal to theta by 1, which is just theta. So these two results we are going to use. Number one is this, and number two is that tan theta is also approximately equal to theta when theta is small. So first we will use for this refraction, we will use the Snell's formula. So you have the Snell's formula right here. We are entering from N1 to N2. So this we had written down as N21. So theta 1 is the angle of incidence. So this I we are denoting by theta 1. So theta 1 is the angle of incidence. Theta 2 is the angle of refraction. So I is theta 1, R is theta 2, and we are just using Snell law here. So by the Snell's law, sine I by sine R is equal to N2 by N1, which is equal to N21. Now you take this theta as very small. So theta 1 and theta 2 are both small. So theta 1 and theta 2 are both small angles. So sine theta 1 is approximately equal to theta 1. Sine theta 2 is approximately equal to theta 2. Now we use the exterior angle formula. So the exterior angle formula says that theta 1 is equal to alpha plus beta. So this is theta 1. So this is exterior angle in the triangle. So this is theta 1. These two are, this is exterior angle. This is equal to sum of alpha plus beta. These two are interior angles. Similarly, you see beta is exterior angle, and this theta 2 and gamma are interior angles. So theta 1 is equal to alpha plus beta. Beta is equal to theta 2 plus gamma. So we rewrite theta 2 here as theta 2 is beta minus gamma. Now you already know about exterior angles. I just want to mention it once more. So in a triangle like this is an exterior angle. So say this is phi, and these two angles are there. So this angle you can say is theta 1, and this angle is theta 2. Then phi is equal to theta 1 plus theta 2. So this is the exterior angle formula, and that is what we are using here. So we have theta 1 and we have theta 2. You plug this and this into here. So that is, this becomes equals to alpha plus beta over beta minus gamma. So this is equal to N2 by N1. Now cross multiply, you get N1 times alpha plus beta is equal to N2 times beta minus gamma. So you take n1 beta on this side, so this becomes minus n1 beta. n2 beta remains here, so you have n2 beta. This n2 times minus gamma you take on the other side, so this becomes, so left hand side becomes n1 alpha plus n2 gamma. You're taking minus n2 gamma on this side, and then you have n2 beta minus n1 beta. So you just rearrange this to get this equation. Now this is one of our equations. This we will use later on. Now you focus on the triangle here with angle alpha. So tan alpha is equal to this height over base. So height is d, base is u. So tan alpha is d over u. Now again, tan alpha is a small angle. You take tan alpha is approximately equal to alpha. Similarly, tan beta is equal to perpendicular over base, or height over base. Height is d and you can see base is r. So you have tan beta is equal to d over r, and you put tan beta as approximately equal to beta. Then you have tan gamma. This is again equal to height over base. Height is d and base is v. So tan gamma is equal to d over v. Again small angle, so tan gamma is approximately equal to gamma. Now you plug the values of alpha, beta and gamma right in this equation here. So in place of alpha in this equation, you write d over u. So you get n1 d over u. So I'm just rewriting this equation down here. Instead of gamma, we write d over v. So you have n2 d over v. So this is equal to n2 minus n1, and in place of beta we have d over r. So you just cancel d out. So you get n1 over u plus n2 over v is equal to n2 minus n1 over r. Now you just replace this u with minus u. Yeah, why do you do that? You do that to adjust for the direction of light. So notice that we are measuring u in the opposite direction. So light is incident in this direction, but we have to measure u from m in this direction. So we are going to go from m to o. So therefore u will be minus u. So instead of u, you write minus u. And therefore you get this formula for the refracting surface. So you have minus n1 over u plus n2 over v is equal to n2 minus n1 over r. Now if it is a flat refracting surface, so flat refracting surface means instead of this curvature, if there was a flat surface, yeah, so if you just enter something like plain glass, so there is no curve, so it's just a plain glass. So if it is flat, then the radius you take as infinity. So if you put r infinity here, then this will become equal to, so this expression will become 0, yeah, because 1 by r will become 0. So this will become 0, and that's what we have taken here. So you have minus n1 by u plus n2 by v is equal to 0 for a flat refracting surface. Now let us see an example. So for example, you take n2 1 as air and n1 is 1.5. This is the refractive index is plastic. So u is 1 centimeter and r is minus 2 centimeters. So r is minus 2 centimeters. So that means the radius of curvature here is negative. So that means we are dealing with, you are entering something like a surface which is like this. So you just plug the values in. So you have minus 1.5 over minus 1.0 plus 1 by v is equal to 1 minus 1.5 over minus 2. So basically we are just plugging in these values here. n1 we are taking as 1.5, u is given to us as minus 1. So we are taking u as minus 1, r is minus 2 centimeters, n2 is given to us as 1. So you plug in, you get v as minus 0.8 centimeters. So that means the image is formed on the same side as the object. So we had a surface like this. So you see that the radius of curvature is negative. So the surface was something like this. And the surface, so the radius of curvature became negative. Yeah, so you had air on this side and this side is plastic. And the ray of light, which I'm going to draw in red, this is going from this side to this side. So it's probably going in like this. And that's why if the object is placed here, the image is also formed here. So this is more like looking into a crystal ball. So this example is like you're looking into a crystal ball. So your eye is somewhere here and you're looking inside a crystal ball.